Okay, so yesterday was like hardcore multiply and divide. We'd done an easy day of multiply and divide, and we had done an easy day of add subtract. So yesterday was hardcore multiplying and dividing. The main theme was if you can factor it, you should. So today, the main theme is hardcore adding and subtracting of algebraic fractions. So what does that really mean? It means you really got to get used to getting common denominators, because on this kind, that's what it's all about. It's about getting the common denominator. So what if I had, we got to make sure you're good at the easy ones first, right? What if I had 1/5 plus 4/7? What's the process for getting a common denominator? Well, you multiply the two denominators together and figure out what you want. I want 30/5, right? Well, what if there had been an x in there? Well, then I'd want 35x. So let's just stop right here and say, okay, I get you would multiply this one by something and you multiply that one by something, and then you get 35ths, and then you'd add them. All right? So what if this has an x in it? It's not like it's all completely different. Now the denominator is just going to be 35x. Do you get we still just multiply these two? And our denominator just is going to be 35x. So what do I need to multiply this by? Well, it's not quite as simple as it used to be. You used to be able to just say, oh, multiply by 5. Vikram, what do you think I'm going to do now instead? Multiply by 5x, because that'll get me 35x. You just keep looking here and say, is this getting me what I want? It is. So Dylan, instead of just multiplying by 7/7, I'm going to 7x makes 35x. See, I get 35. Oh, wait a minute. I get 35x squared. Jack, what did I do wrong?
Wouldn't you just multiply by 7?
You would just multiply it by 7. Now, I'd said instead of multiplying by 7, we should just, so I was kind of leading that we should do something else, and that's what people are going to do. They're going to just multiply both sides by x, and then it all of a sudden isn't going to work. You got to look and see, did I get what I wanted? I was going to get 35x squared there. That's not what I wanted. So now it'll be a 7 and a 5 makes 35x. So this one's just 7. And the top of this one will be 20x. So what's the answer? 20x plus 7 over 35x. What happened at the end there? You just add these, and the bottom stays the same. All right, let's see if you really got that. 2/3 plus 1/4 would be too easy. So let's make it 1/4x. Now that's an algebraic fraction problem. You can't multiply by something unless you know what your target is and what your goal is. It's kind of like you in life. You can't figure out what classes you should take until you kind of know what you want to be. My daughter was sure she was going to be a pharmacist. She thought that would be a great career, and it would be, by the way. They get paid really well. Pharmacists start at about $120,000. And you can get a pharmacy degree only 6 years after graduating from high school. 120 grand? That's a good income. Just for perspective, a starting teacher might make 40. So you make triple what a teacher makes. You just have to go to 6 years of school instead of 4. And you got to be able to handle some pretty decent science and math. Not a lot of math, but you have to do a little bit of math. My point, that was a great plan until she realized she didn't actually like it. How'd she figure out she didn't like pharmacy? Because she went and worked at a pharmacy for a while, not just like a day. She worked there for a few months. And then she was like, this sucks. I don't like this at all. So even though the money was going to be good, she was like, I don't want to do it. So she changed her mind and decided to go on to become an engineer. She's now about to graduate and be an engineer. She seems to be much happier with that choice. And she'll still make good money, but she won't start at 120, that's for sure. She might start at like 70 as an engineer, which is a lot more than 40 as a teacher. But she starts at 70 and does a great job. She'll eventually get up to that 120, and she'll like her job better. So, what's my point? If you don't know where you're going, then how are you supposed to figure out what you should do next? You know, like if I said, hey, go to my cabin. You're like, well, okay, well, where is it? All right, you need to know where it is to plot a course. So if you can figure out where you want to head, you can even change your mind, but you got to be heading somewhere. So I encourage you to pick something that you think you're interested in and aim at that in life. And then you can always make adjustments. And it worked out just fine. It would be perfect if you knew what you wanted to do right now, because then you could easily chart a course on how to get there. So if you know for sure, do any of you know for sure, like, I want to be a blank, I want to be a nurse, I want to be a doctor or whatever. Anybody willing to share? Like, right now, I really want to be a blank. What would you like to do? Neurosurgeon. Fantastic. So you got a course then. You can go, okay, to do that, I need to get good grades in high school so that I can get into a good undergrad program. And then after your undergrad, you want to get good grades there too so you can get into the med school. You might be thinking about, like, it's expensive, right? So you got to be thinking about, how can I do that? By the way, the military, if you decide you want to work for the military, they'll pay for all of your stuff. Like, literally, they'll pay for everything. You can't just, like, at the end, though, now that you're a doctor, you can't just go, and now I quit. You have to stay. And it's basically, the deal is, for each year of school we paid for you, you have to work for us for a year. So if you're going to be a doctor, that means like 12 years of getting all your doctor stuff. So you got to work for the military then for 12 years. But then when you come out, you don't have any debts, and they paid for all your school. And so there's an example. That's awesome. Thank you for sharing that. Anybody else think you have a plan? You know what you want to be? And it's okay to not know too, because eventually you just kind of aim at something, and then you can always change your mind. All right, so what am I aiming at here? I am aiming at trying to get these guys to make a common denominator. What do you think the common denominator should be? 12? 12x. So now that you know your goal is 12x, then you can be thinking, how can I make that work? So Joey, what do you think I should multiply by to get 12x to come up? On the right, you're going to times by 3. Very nice. On the left, 4x. On the left, nice. And then that makes 8x over 12x plus 3 over 12x. Mr. Moore, can you tell me the final answer? All right, the only thing you dropped was, you dropped an x. Remember how there's an x up here? So there should have been an x right there. There you go. So now we got an 8x plus 3. And this brings up an important point. 8x plus 3, is that 11x? No. It would have to be 8x plus 3x. So it's 8x plus 3, and that's it. Done. Now, I do always say, if you can factor it, you should. Like, if this had been a 4 right here, 8x plus 4 would have factored. And then 12x could have had a 4 in it also, and then you could have factored it out and canceled it. Let me just show you that. In an alternate universe where the problem ended like this, do you remember my deal about if you can factor it, you should? Everybody take this red one, factor it down, and cancel stuff. You got to be able to look for that and cancel stuff when you need to. right, so I see a 4 in both of these. Take a 4 out of your 8x. Take a 4 out of your 4. Really what that means is divide by 4 here, divide by 4 there. Angela, what do you think you get when you take a 4 out? What do you get for this part?
2x.
Nice. And what do you get for this part?
1.
Yep, very nice. Alisa, how about the 12x? All right. So 4 comes out, and I have 3x. I assume that's what you meant. Is that what you meant? Is that what you meant? Did I ever draw it right there? Because see, the 12x changes into 4 times 3x. Okay. All right, so then, why did I do that? Jack, final answer.
It would be 2x plus 1 over 3x.
So these guys disappear. 2x plus 1 over 3x. Okay. Let's do another one. 7 over 9x plus 1/3. Come on, hang in there with me. You can do this. Know where you're going. What's a good denominator? Just x? I can't just have an x. Could I have a 3x as my denominator? Nope. What do you think we should use?
9x.
You went fancy. You can make these both be 9x. Now, I was expecting 27x, and that would be great. But do you get that 9x would also work? This is not, like you have to do it her way. But she wants to use 9x, and it'll work. Because see, the beauty is, that guy doesn't have to be multiplied by anything. And this one has to be multiplied by, what do you think, Elisa? 3. Now I got it to 9.
Oh, I thought you were doing the other one.
Oh, okay. How about if we do want to do this one, do you get I'm close to having them both be 9x? I just have to make a little tweak. Don't just multiply by 3. 3x. Now they both have a 9x denominator. 3x here, 7 here. Add them. Matilda, final answer.
7 plus 3x over 9x.
Yep. I saw some kids wrote this, and that's fine, and what she said was fine. You can say 3x plus 7 or 7 plus 3x over 9x. Nice. Can that be factored? Because if you can factor it, you should. No. Imagine an alternate universe where it had been like this. 3x plus 3 over 9x. Everybody imagine that's what the answer was. And if you can factor it, you should. Everybody, do that factoring thing. I'm telling you, you've heard me say it now probably 45 times. If you can factor it, you should. You got to say that to yourself on this next test, because I'm telling you, there's going to be factoring a lot. And when you don't factor it, you leave it unsimplified, you lose points. You definitely need this factored. Martina, what comes out on the top? You got 3 coming out, and you got what left? What goes in here?
Oh,
Yes. And Martina, how about the bottom? If you factor a 3 out of that, what's left?
3x.
Yes. Alban, final answer.
1x plus 1 over 3x.
You got it. You canceled these, right? There you go. Now, is it okay to just say x instead of 1x? Yeah, they're the same thing. 1x and x are the same thing. So, okay, cool. I feel like you're getting it. Everybody, find this problem. If you need to, this is the part where you want to get the notes downloaded. It'll make it go faster. Find this problem. We're going to be done here very soon. But get with me on the notes as quick as you can. Jack, do you feel like they need to be multiplied by anything to get a common denominator? Nope. They have a common denominator. So this is really pretty simple. We know the denominator is 5x squared minus 6x plus 1. Then, Lily, what's the top going to be?
Would it be 10x plus 4?
6x and 4x makes 10x. Positive 5, negative 1, plus 4. Nice. Now, just a quick check. The top can be factored. What could factor out of the top? A 2. But does the 2 come out of the bottom? No. So then you can stop right there. You don't need to factor it unless when you factored it, stuff would cancel. So yeah, you could factor the top, but you don't have to because the bottom doesn't factor enough to cancel anything. So that's it. Done. You sit in the end, all you had to do is add the top. Some of them are that easy. This one's that easy, except it's got a minus in there. And that minus gets so many people because they forget to distribute it. Don't let it get you. Remember me showing that video of the monkey playing Pong with its brain? I guarantee you there was a neurosurgeon involved there. That was to put the hardware into the monkey's brain to be able to make it connect to the computer. We'll be doing so many amazing things in the future. It's just growing exponentially. It's like this is what technology is doing. And that means you guys are like here. You guys in about 20 years are going to be like here. It's going to be so much more than it is right now. It won't be long at all. In video games, it'll be really hard to distinguish them from real life. Like when you're playing in a video game, you will feel like you are actually in real life, actually there. Because they're going to have suits you can wear so that all of a sudden you can feel stuff happening to you. You know, like you can feel like you just got hit. Or you can feel like, you know, when you do jump underneath something, you can like feel yourself like bumping up against the rock that you're hiding behind or whatever. That's going to get more intense. Movies are going to get more intense. I think they're going to have 3D movies where you're in the movie and you can like turn around behind you and see people sneaking up behind you in a movie. Like you'll have virtual, you know, like 3D goggles on where you can turn your head and see stuff. You're in the movie. You're like riding on a horse next to the guy in the movie. And you can look to the left and look to the right, look behind you. Anyway, I'm a believer that tech is changing so fast that it's just hard to imagine what's going to be happening next. All right, so if you're going to be a part of that at all, it's going to involve math. On the top, I have a 5y squared, but I don't have any other 5y squareds. So I'm just going to put 5y squared on the top. Mr. Vikram Nathan, can you tell me what to do with this 2y? Minus 2y. You didn't put it with anything else. Why didn't you put it with anything else? The way you'd say it is because there's no like terms. There's nothing else with a y. And I'm going to make a mistake on purpose here, Mr. Moore. This negative 10 and this 7. If I put them together, I'd get negative 3. Why is that wrong? Yes, there's 2 negatives on it. So that's positive 10. So what should it be actually then? So this is positive 10 and positive 7. There's no minus. 17. There it is. Put your hand up, either virtual hand or real hand if you had that one right. Okay. Now, I'm going to get to one of those tough kind like I just did a minute ago. That does not have a common denominator. You got to think, okay, what do I want the common denominator to be? And what should I multiply by to get there? A good denominator that would be a common denominator would be 5 times b plus 2. Now, could you multiply that out and say 5b plus 10? Yeah. But I'd rather have it factored, because if you can factor it, you should, right? So I think it's better to just leave it like this, 5 parentheses b plus 2. That's my denominator. Does this have that denominator? No, so I got to multiply by something. And in the blue parentheses, I got to multiply by something different over there so that I get my goal. My goal is having a denominator of 5 parentheses b plus 2. Alban, can you tell me what you think we should put in the red parentheses on the left side? Yes, we put a 5 here and here. Dale and Thomas, can you tell me what you think we should put in the blue parentheses? B plus 2. Bennett, I'm going to write it this way. 5, 5b plus 3. And 2, b plus 2. Now, I want your opinion. Do you think that I should multiply these out? Or do you think that I can just leave them like they are? What's your gut feeling? It's a test. You're deciding what the answer is. You've already got a denominator of 5b plus 2. Do you think we should multiply the top out, or do you think we should just leave it? Yep. So help me. What's the 5 times the 5b? It is 25b plus 15. Do you know what the next step is? Okay. You can multiply the bottom out. You can, but let's finish this part over here, right here. Can you tell me that part? Because we got to add that to the top. That's it. Plus 2b plus 4. Joey, we're not done. Finish the top. You can do this. You would. What's that? 27b plus, and the denominator is 5b plus 10, or 5b plus 2. I actually think you should leave it factored. You know why? Because you can factor it. You should. Oh, yes.
Would it be 20b or 27b plus 20, not 19?
Isn't 15 and 4 make 19?
Oh, no, wait, never mind.
That's all right. It's all right. I'm glad that you feel confident enough to ask, because you do know I make mistakes. So please don't feel bad about asking. All right. So all I left this factored for was so I could see if maybe this would factor. But 3 goes into 27, and 9 goes into 27, but pretty much nothing goes into 19. You know what I mean? So I don't think I can factor the top. So then I'm done. That's my answer. Always look to see if you can factor it. You should. Because if you can factor it, you might cancel something. All right. Last one. Last melon. Now we start the homework. Yes? You don't have to because it's factored form. And you know, if my saying is if you can factor it, you should, then I'm fine with leaving it in factored form. If you want it distributed out, it's also okay. Both are right. Yep. I just think the factored form is better because that way you can check if anything would cancel. So I like to leave them factored if you can, but you don't have to. The only place you get burned is if you could have factored the top and the bottom and you didn't, then it wouldn't be reduced all the way. All right, so this is the toughest one. Well, remember, think ahead. Trying to use strategy here. I'm going to multiply both sides by something. You always have. You've never added anything to the top or the bottom. We always just multiply by the top. Multiply on things on the top and the bottom. And we need a denominator that's common. I have two fractions. They both need a common denominator. And here is your common denominator. That's the common denominator. So you figure out how to finish this thing. If that's the common denominator, figure out what you're going to need to multiply by to make it happen. This is going to get detailed, and I will lose a few kids that can't handle the detail. But math rewards careful people. It'll be the careful people that get the A's. You might even know that you're supposed to multiply this one by d minus 4. But if you can't actually do it, you don't know how to actually multiply that out, then this one by d minus 1 and this one by d minus 1. You might know you're supposed to do that, but if you can't actually do it, that's what's going to keep you away from the A. So let's distribute this thing out. D to the 4th times D. How many of you knew that was D to the 5th? Put your hand up if you knew that was a D to the 5th. Okay. And then D to the 4th times negative 4 minus 4D to the 4th. Now, if you forgot already that this negative was here, you were going to lose points. Because that negative is really on this 3, and you're going to distribute that negative in here. You know how the negative getting distributed is one of the most common mistakes? Yes? It is a plus 1. Thank you very much. Just said a second ago I make plenty of mistakes. There's one of them. Those are supposed to be D plus 1 on the top and the bottom. Natalie, can you do this part? Negative 3D squared times D. That 3 is not getting squared. So fundamentally, I'm going to highlight them just to make sure you get which two are multiplying. Negative 3D squared times this D. There it is. Negative 3D to the 3rd. Okay. Alban, can you do the last one?
Is it minus 3D to the minus 3D squared?
Yep, because that times 1 just keeps it the same. Negative 3D squared. Remember, math rewards careful people. We were careful with our negative, so we distributed about to both. And now that's a 5th and a 4th and a 3rd and a 2nd, and they're all in order, which is awesome. So that's my answer. d to the 5th minus 4d to the 4th minus 3d to the 3rd minus 3d to the 2nd. That went in descending order, just like it's supposed to. And on the bottom, could I multiply it out? Yes. Do I have to? No, because I've said before, if you can factor it, you should. So look, it's factored. Awesome. And I don't see anything that can cancel, so then I'm done. If you had multiplied the denominator out, I wouldn't have marked it wrong, but that is some seriously intense math. All right, now we'll see if anybody fell asleep during that, because this is the part where we turn to the homework. Everybody, right now, find the Schoology quiz that's got today's date on it, 4/30. It's in that folder, and that's all I have for the video for today. Today's homework is in the folder called April 30th.